Most people assume that living without air conditioning just meant being miserable all summer. They picture frontier settlers sweating through July in a dark log cabin, suffering in the heat because they had no other option. That picture is partly true, but it is not the whole story. The part people leave out is that builders and settlers understood some genuinely useful principles about heat, air movement, and shade. They did not always apply those principles perfectly, but the ones who got it right lived noticeably more comfortably than the ones who ignored them. And here is the thing that really gets me. Some of those same principles are being completely ignored in modern construction, and people are paying enormous electric bills because of it. Hit subscribe before we get into it, because some of these old techniques are more useful than the expensive gear people buy today. I'm Jerry Davis, and one thing old cabins teach us is that good construction has always been more about understanding heat, air, water, and materials than buying the newest product. When you study how frontier builders and settlers managed summer heat, you start to notice the same ideas appearing over and over in different regions with different materials across different time periods. That consistency tells you something. These were not decorative choices. They were functional ones, worked out through trial and error, and passed along because they actually helped. Let me be clear about something up front. Frontier summers were genuinely brutal for a lot of people. Poor settlers working long hours in direct sun, wearing heavy clothing, cooking over open fires, living in small structures with low ceilings and no cross ventilation, those people suffered. The techniques I'm going to describe helped, but they did not turn a log cabin into a comfortable modern home. The goal was survival and basic livability, not luxury. Keep that in mind as we go through this. Let's start with site selection, because this is where everything either begins well or begins badly. When settlers chose where to build, the ones with any experience thought carefully about which direction the cabin would face, which trees were nearby, and what the local wind patterns looked like. A cabin built on a hillside that caught prevailing summer breezes was going to be more comfortable than an identical cabin sitting in a hollow where hot air collected and barely moved. Historical land surveys and settlement accounts describe this kind of thinking clearly. People chose elevated, open sites when they could, partly for defense, partly for drainage, and partly because a bit of wind made summer heat far more tolerable. The orientation of the cabin mattered too. Builders in most of North America understood, whether they could have explained it in scientific terms or not, that the long axis of a cabin oriented roughly east to west meant the south-facing wall got the most sun exposure. That sounds bad until you think about the roof line. A proper roof overhang on a south-facing wall can block high summer sun, which travels a steep arc across the sky, while allowing lower winter sun to reach the wall and contribute warmth. Period construction guides and surviving cabins both suggest this was a practical consideration, not an accident of layout. Here is what most people get wrong about this. They think settlers were just putting cabins wherever the land was flat and ignoring everything else. Some did exactly that, and their accounts describe miserable conditions as a result. But experienced builders, people who had watched a place through a full year, or who learned from others who had, were making real decisions about heat, shade, and airflow long before any of those concepts had formal names. Now let's talk about windows, because this is where frontier construction gets genuinely interesting and often misunderstood. Small windows are usually interpreted as a sign of limited materials, security concerns, or a simple lack of sophistication. And those reasons are all partly true. But small windows also have a functional relationship to heat and cold management that builders understood at a practical level. In winter, a large window is a massive source of heat loss. In summer, a large window facing west turns your cabin into an oven every afternoon. Frontier builders commonly placed windows strategically, not large ones facing the setting sun, not gaps in the walls facing the coldest winter wind. And this was not accidental. The placement of openings for cross ventilation is the detail that gets left out of most discussions. Two small windows placed on opposite walls of a cabin create airflow in a way that one larger window on a single wall never can. If those openings are positioned with some understanding of prevailing wind direction, the effect is even better. Historical accounts from settlers in the southern states describe opening low windows or gaps on one side and high vents or gaps on the opposite side to create what we now call stack ventilation. Cool air drawn in low, warm air rising and escaping high. They did not call it that. They just knew it worked. I want to stop here and say something important. Not every frontier cabin had good ventilation. Many had terrible ventilation. People got sick, they suffered from heat, they dealt with smoke problems because poorly designed chimneys and fireplaces interacted badly with airflow. I am not describing an idealized frontier cabin. I am describing what the better built examples did and why it worked. The range of quality in historical construction was enormous. Let me talk about roof construction next, because the roof is doing more thermal work than almost any other part of a structure. A low-pitched roof holds heat. A steep-pitched roof creates an attic space, and that attic space, especially if it has ventilation openings at the gable ends, acts as a buffer between the direct summer sun beating on the roofing material and the living space below. Surviving construction manuals from the 19th century describe this principle in practical terms. The air in a ventilated attic space moves through and carries heat with it, rather than transferring all of it directly into the ceiling below. Some settlers in regions with severe summer heat went further and built sleeping lofts in the upper portion of the cabin, with the understanding that sleeping up high in summer was actually cooler, because air movement near the ridge was better, not warmer, as you might assume. This sounds counterintuitive, but good ridge ventilation can create enough airflow to make the loft more comfortable than the floor level on a still hot night. The trade-off is that in winter, the loft is harder to heat, so sleeping arrangements sometimes shifted seasonally. Historical family accounts describe exactly this kind of seasonal adaptation. Sod and earthen roofs come up a lot in these discussions, and I want to address them carefully because the popular understanding is pretty mixed. Sod roofs, common in treeless prairie regions where timber was scarce, do have genuine insulating and thermal mass properties. The earth absorbs heat slowly and releases it slowly, which can moderate temperature swings inside. But here is the problem. A properly functioning sod roof requires excellent structural support to handle the weight, effective waterproofing underneath to prevent leaks, and careful management of drainage. Many sod roof structures leaked badly, had serious moisture problems inside, and created pest and air quality issues that offset whatever thermal comfort they provided. Archaeological and historical records both describe the ongoing maintenance burden of sod construction. Prairie settlers did not choose sod roofs because they were the best option. They chose them because wood was not available, and they needed something. Now let's get into what settlers actually did inside the cabin to manage heat, because building design only takes you so far. One of the most consistently described practices across frontier accounts is controlling when and how much cooking happened during summer. Open hearth cooking generates enormous heat inside a structure. Period accounts and domestic guides from the 18th and 19th centuries describe moving cooking activities outside during summer, using outdoor fire pits, summer kitchens built as separate structures, or simply doing heavy cooking in the early morning before the day heated up. A separate summer kitchen, built with good ventilation and positioned downwind of the main dwelling, is described in accounts across different regions and periods as one of the single most effective ways to keep a home comfortable during hot months. This is the part worth copying if you have any kind of off-grid or rural setup today. A separate outdoor cooking area keeps the heat source outside the living space. It is not complicated. It is just practical. Thermal mass is another concept that frontier builders used without necessarily naming it. Heavy log walls, stone foundations, dirt floors, and thick clay or lime plaster all absorb heat during the day and release it slowly at night. A well-built log cabin with thick walls and a stone hearth does not heat up as fast as a thin-walled structure, and it does not cool down as fast either. In a climate with hot days and cool nights, this is a real advantage. The structure stays more moderate than the outdoor temperature swings would suggest. But I want to be honest about the trade-off here too. A dirt floor, which many cabins had through much of the frontier period, is thermally stable and inexpensive. However, dirt floors also create serious moisture problems, can harbor pests and parasites, and have genuine health and sanitation implications that period accounts acknowledge and that modern building science confirms. If someone tells you a dirt floor is a lost wisdom technique worth reviving for your homestead, ask them about groundwater, radon, moisture vapor, pest management, and air quality first. Some people make it work with proper drainage and lime treatment, but it is not a simple or automatically comfortable choice. Let me talk about shade, because I think this one gets undervalued in historical discussions. Covered porches, described across frontier construction from early settlement through the 19th century, were not primarily decorative. A deep porch on the south or west side of a cabin keeps direct afternoon and summer sun off the wall and windows entirely. A shaded wall does not transfer heat into the interior the way a sun-baked wall does. Period accounts describe people spending most of their waking summer hours on covered porches for exactly this reason. It was genuinely cooler than being inside a cabin that had been absorbing sun all day. Planting large deciduous trees on the south and west sides of a structure is mentioned in 19th century agricultural and domestic guides as a practical, long-term strategy. Deciduous trees lose their leaves in winter, allowing winter sun through when it is wanted, and provide full shade in summer when it is not. This is not folk wisdom. It is a reasonable application of how deciduous trees behave seasonally. The catch is that it requires long-term thinking. Planting a tree that will not provide real shade for a decade or more, which was a different kind of investment than most immediate survival decisions. Underground structures come up regularly in frontier cooling discussions, and they deserve careful treatment. Root cellars, dugout shelters, and partially submerged structures all benefit from the fact that ground temperature below the frost line stays relatively stable year-round, typically in a range that most people would describe as cool in summer and unfreezing in winter. Historical accounts and period guides describe using root cellars and similar underground spaces as cool storage for food, dairy, and sometimes as sleeping spaces during extreme summer heat. Ground temperature at sufficient depth in most of North America stays somewhere in the range that reflects the average annual temperature for that region. Cool but not cold in summer, not freezing in winter. But here is the honest accounting. A poorly drained root cellar or dugout structure is damp, prone to mold, has air quality issues, and can develop structural problems from moisture and frost pressure over time. Period medical accounts describe the health problems associated with damp, poorly ventilated sleeping and living spaces. Calling every underground structure a clever frontier cooling system ignores a significant portion of how they actually functioned in practice. Springhouses are worth a specific mention here because they represent one of the more elegant cooling solutions in frontier history, and one that actually worked quite well within its intended scope. A springhouse is a small structure built directly over or adjacent to a cold water spring, using the cold running water to keep the interior cool, typically cool enough to store dairy, meat, and produce at temperatures meaningfully below the summer outdoor air. Historical accounts, surviving structures, and period farming guides describe springhouses as a central feature of farms in suitable regions throughout the 18th and 19th centuries. The cold spring water circulates through troughs or channels inside the building. The structure shades and encloses the spring, and the combination creates a reliably cool storage environment. The limitation is obvious. You need a cold spring in the right location relative to your dwelling. You cannot build a spring house without one. This technique was regionally specific and required a particular landscape feature most settlers did not have access to. But where it existed, it worked. And it worked well enough that many examples survived into the 20th century and continued to be used long after refrigeration became available, because they were free to operate and required no power. Let me talk about clothing and personal cooling for a minute, because the building is only part of the picture. Frontier accounts describe loose, light-colored, natural fiber clothing for summer, linen being particularly valued for its ability to wick moisture and dry relatively quickly. Wool, which is excellent for cold weather insulation, was largely set aside or worn in lighter forms during summer. Period accounts describe soaking clothing or bandanas in cold water, using wet cloth on the neck and wrists where blood vessels are close to the surface, and seeking shade during the hottest part of the day, rather than working through it. None of this is surprising, but it is worth saying clearly, the behavioral adaptation was as important as the structural one. You cannot build your way out of all heat. You also change when and how you work. Midday rest during summer, sometimes called the frontier equivalent of a siesta, though that specific cultural term belongs to a different tradition, is described in accounts from settlers, travelers, and period guides as a practical response to summer heat. Working hard in direct sun during the hottest hours of a summer day without adequate hydration and cooling was dangerous. Period medical and practical guides acknowledged this directly. The people who ignored it sometimes paid a serious price. Here is the part that I think is most useful to pull forward into today. Site selection, orientation, roof overhang, cross ventilation, shading, thermal mass, separating heat-generating activities from living spaces, and using whatever natural cooling resources exist on a property, spring, shade, elevation, wind, are all still functional principles. None of them require expensive technology. None of them are outdated. Modern building science has confirmed and refined the understanding behind all of them. What modern construction sometimes does instead is build structures that are thermally inefficient, poorly oriented, and heavily dependent on mechanical cooling to compensate. That works fine as long as the power runs and the equipment is maintained. The frontier builders did not have that option, which forced them to get the passive design right in ways that are genuinely instructive. I am not suggesting anyone abandon air conditioning. That would be foolish advice. But if you are building or retrofitting a cabin, rural home, or off-grid structure, the principles I have described can meaningfully reduce the cooling load, lower energy costs, and make the space more livable during power outages or equipment failures. That is worth understanding, regardless of whether you have any interest in historical living. Can we please stop pretending every old method was better? Some of it was not. Some frontier buildings were miserable in summer because the builder made bad decisions, had no experience, or had no real choice in materials or location. But some of it was genuinely good applied physics, heat management, airflow, shading, and thermal mass, working together in ways that a thoughtful builder today can absolutely still use. The old-timers were practical, not magical. They were working with what they had in places they could not always choose, with knowledge passed along imperfectly through experience and oral tradition. What they got right, they usually got right for functional reasons. That is worth studying. Just study it honestly. I'm Jerry Davis. Thanks for being here. Subscribe if you want more of this practical history, real trade-offs, and no Hollywood nonsense.